Hello everyone, my name is Dennis Wagelaar and I will present the transformation tool contest case of transforming KMEHR to FHIR. First of all, some background. I'm working for a company called Corylus, and Corylus develops software for first-line healthcare practitioners such as physicists, pharmacists, dentists, nurses. For that purpose, we often need to be able to exchange medical records of patients, and that is basically what this transformation tool contest case is about. So I'll give you some context. What is KMEHR and what is FHIR, and why do we need to transform one into the other. Then I will explain the case structure that we've chosen for this assignment, task description of what the participants had to do in order to implement their part of this case, and finally I'll explain the benchmark framework and evaluation for this case. So, some context about KMEHR. What is KMEHR? KMEHR is actually a Belgian medical data standard for medical data exchange that's been introduced in 2002. It stands for Kindly Marked Up Electronic Healthcare Record. KMEHR is also divided into profiles, 20 specific XML messages that you can send using the KMEHR syntax, and one of which is the summarized electronic health record, or SumEHR. The SumEHR is for exchanging a minimal set of data between physicians and hospitals and actually caregivers all alike who need a sort of emergency record to understand what the risks are and what the specific context of that patient is before providing treatment to that patient, and that will help a lot in patient safety. This was introduced in 2005, so it's already been around for quite a while. And actually all Belgian medical software has to be capable of exporting a SumEHR message for a given patient. This is basically what a SumEHR message looks like, embedded in KMEHR. It's set up as a message, so the header contains a couple of semantic anchors in there, like the CD system is the coding system that you use. In the world of medicine, they use a lot of coding standards to make sure that everyone is talking about the same thing. In case of medication, vaccines, also diagnosis, this is very important that you don't just put free text information in there, but you actually attach a code to a diagnosis or to a medicine that you've administered, such that it's absolutely certain that you're talking about the same thing. It's put in the form of a message with a sender and a receiver, and basically here with the sender you can see this is how doctors are referenced in a KMEHR message. There's some personal details in there, what kind of caregiver it is, so this is a physician. There's a registration number for physicians and hospitals alike. It's called a NIHI number. It's a national registration number for caregivers in Belgium, and this way you can again pinpoint the particular caregiver. So if you look at the SumEHR body, then there's first the patient in there, which is again pinpointed whenever possible with their social security number. Then there is the actual body of the SumEHR message, which is in a transaction block here. The transaction block is typed with a code, CD transaction. It's typed as a SumEHR. Any software processing this knows that it's looking at a SumEHR message. There's an author, which is again one of those healthcare parties that you saw in the previous slide. And then here are the medical items. So there's a whole list of medical items inside this transaction. And this is an example of a contact person. Other medical content, of course, also goes in item blocks, such as problems that pre-existed, medication that's been administered, vaccines that have been administered, any allergies that we know of. They're also put into item blocks inside this transaction. Now we're going to look at FHIR. FHIR is an international standard developed by Health Level 7. And it's been introduced in 2011. It builds on previous data formats that have been around for quite a bit longer. That's HL7 version 2 and version 3. Version 2 was plain text and version 3 was XML. The actual modern standard of FHIR, which is expressed mostly in JSON but is also possible to express in XML, has only been introduced in 2011. So in the case of Belgium, they started with KMEHR in 2002 and SumEHR in 2005. They predated this. So now FHIR also offers something called an international patient summary, which is again a profile that you can apply to a FHIR envelope. So FHIR is just the format that you can put it in, and one of the usage profiles is to put an international patient summary in there. So that's basically the same purpose as a SumEHR document. So now it becomes very interesting to translate a SumEHR record into this more modern format of FHIR International Patient Summary. So this is what a FHIR International Patient Summary document looks like. In FHIR you wrap everything inside a bundle. In this case it's a document. There's no sender and receiver in International Patient Summary. All the information, the header information, goes inside a composition element. That is basically serving as a table of contents of what sits inside the FHIR document. Again, you see a lot of codes. In the case of FHIR, we work with lots of identifiers. Here we generate an identifier that we can reference to in other parts of the document. The document is coded as well. There's an OID code that points this out as a FHIR IPS document. There's also another coding system called LOINC, and they also have a specific code for patient summary document, and that code has also been added to this document. This whole composition block runs on to pinpoint the subject of the international patient summary, which is a patient. There's a reference in there again, and same as for medical data, these references are actually added outside of the composition block. This is where the sections start. The sections are concerning different topics, such as medication. Again, there's a coding included. Coding system is again LOINC. There's a code, and this section is about the history of medication. Then there's the actual medication. That's just the reference again. We're going to look at an example of the reference. Here you use another coding system. In this case, we use the Belgian CNK code system, which is the barcode system that you find on the medication package. That uniquely identifies a medication and package in Belgium. Now, of course, if you want to use this internationally, this is not good enough. Usually, healthcare providers abroad will not be able or in the opportunity to look up the Belgian coding systems. So it would be best to translate this to an international coding system. That's a bit beyond the scope of this assignment. That's a brief introduction into the formats and specifics of SumEHRs and FHIR IPS. Now we're going to look at the case structure. In order to deal with SumEHR documents and FHIR IPS documents, we started off with the XML schema of both document grammars. So I know that in the case of FHIR, it's customary to represent FHIR documents as JSON, but FHIR also does provide an XML schema. And for implementing this case on top of the Eclipse modeling framework, this is a lot easier, as the Eclipse modeling framework is able to just import an XML schema and generate a meta model for it, an eCore meta model. So this is what we've done. We've taken the XML schema of KMEHR, which is the actual representation format. Then we've taken the XML version of FHIR, and we've basically generated eCore meta models for KMEHR and for FHIR. Then we've also provided an example KMEHR document and example reference transformation that will translate the KMEHR document to a FHIR document. This is basically broken down into two files: the main transformation file with the transformation rules in there, KMEHR to FHIR.atl, and a library with a number of helper attributes and methods. We've also provided additional versions of this KMEHR file that are basically sized up. So I haven't included that on this slide, but there are larger versions which include every element times 10, times 100, times 1000. That basically exercises your transformation to see if it can scale to larger documents. But to be fair, in real life, these summary medical records tend to be rather short, so it won't be larger than the times 10 document in the worst case. This reference solution in ATL actually showcases a new feature of EMF-TVM 4.8, which is a local search plan compiler. Whereas typically in ATL you had to be very careful when putting multiple elements in the input part, in the from part of your rule, because it would iterate for every element over the entire model, effectively causing a Cartesian product style matching. In EMF-TVM 4.8, it actually uses the filter expression here to see if it can do a local search for certain input elements. In this case, we conveniently use this to have access to all these model elements when we are actually writing out our target model elements, and we don't have to write expressions in a using block trying to find all these elements separately. We just write them all in one place. These are all the model elements from the input model we're going to use. These are the constraints, how they should relate to one another. And then you can simply write what you want to generate. Now in this case, the TX, the I, and the S input model element are actually bound to other model elements, and you don't have to look at them globally. So I took an example here for finding TX. TX is actually included in the transaction property of the folder. So the folder is not bound anywhere. We have to actually iterate over the model to find it. You can also see it in the bytecode of the EMF TVM file. The folder element here doesn't have any code underneath it. You just have to, the engine just has to find it. But the TX, I, and S element have code blocks underneath, and those code blocks will basically return the possible candidates for matching. So in this case, we take for the TX element f.transaction. That typically returns a sequence of transaction elements, and we're just going to try and match the TX against that. Same thing for the item type element. Item type is also bound. You see that the transaction.item has to include the item, so you can expect a code block here that will load tx.item, and finally the posology for an item is done in the same way. You just load i.posology and you match that for S, which is basically a single item. This makes it much faster to find elements that are local to the main input element. What is a posology? Posology is basically how much and when you should take the medication. The task description, what do you have to do with all this? The first one's obvious. I'd like you to re-implement or improve the original transformation that translates SumEHR documents into FHIR IPS documents. And it would be good if you could do it in a way that lends itself better to after-the-fact consistency checking. It's medical information. It's quite important that it is consistent medical information, and the output is a true representation of what you put into the transformation. An optional task is to also define the reverse transformation that would translate the generated IPS documents back to SumEHR documents. That would make it easy for existing software in Belgium to read emergency medical records from people from abroad. This is something that I did not provide a reference solution for, but it would be great if you would find time for that. So finally, the benchmark framework and the evaluation. Benchmark framework, I basically copy-pasted from the Transformation Tool Contest 2017. That framework included 3 phases for measuring the performance and memory usage of, that's the initialization phase, the loading phase, where you basically load your transformation, your models, and finally, when everything is in memory, you run the transformation and you measure how much memory that takes, how long that takes. Each solution is required to output CSV, to standard out. That actually records statistics of every phase of the benchmark. And it has to record the tool name, the source model, the target model, the run index, like we run the benchmark multiple times. So there will be the run index of which run it is in there, the phase name, whether it's initialization, load, or run. And then you can record a number of metrics. So in every phase you can output multiple CSV lines with multiple metrics. You can look at the reference solution for the complete information of what you can do here. And there's also a solution.ini file, and that's basically telling the framework how to run the solution. To run the benchmark, you require Python version 3.3 or higher. Finally, the evaluation. The criteria that were in the paper is how efficient is the approach in time and space, so CPU and memory basically. How understandable is the transformation code for domain experts to review and validate. There's some extra criteria that you can basically infer from the task description, and I'm very interested to see what comes out of that as well. So from the task description, it was asked to look into after-the-fact consistency checking. Did you generate a consistent output model from the input model? And it would be good to evaluate how well the approach lends itself, the particular tool you've chosen, how well it lends itself to do this after-the-fact consistency checking. Finally, did you implement the optional task? And did the chosen tool provide support to make the optional task easier? Given that you have a transformation that goes from KMEHR to FHIR, is it actually easier to implement FHIR to KMEHR? So that's it. Then I would like to thank you very much for submitting a solution to this case, and I wish you all good luck in the contest.